In one of my previous videos, I talk about how to collate inverter loads and how to size the inverter itself. But in this video, I'm going to talk about how to calculate the capacity of inverter battery bank in ampere hour. Please welcome to my JK Multimedia Solutions channel. Please do subscribe to my channel and follow me in this video as I talk about inverter battery bank calculation and sizing. Alright, inverter battery bank calculation, inverter battery bank capacity in ampere hour is given by, this is the formula. This is the capacity in ampere hour is equal to S times T, then divided by V times this meter times DOD, where ampere hour is where AH is ampere hour, S is equal to inverter load apparent power. Is apparent power in this situation, not wattage. If you use wattage, it's like the battery bank will be undersized because the apparent power comprises the active power component as well as the reactive power component. So, but whether the reactive power component or the active power component, they are all coming from the battery. So we have to use apparent power. T is equal to inverter backup time. That is the time that the inverter will be in use when there is power interruption. V is equal to inverter battery bank voltage. Meter is battery efficiency. DOD is battery bank depth of discharge. For instance, if the batteries, if 70% of the battery capacity is used, then it means the depth of discharge is 0.7 or 70%. Alright, so I'm going to use a practical example to illustrate the concept. Please follow me. Example: the inverter load of a particular building is 3,550 watts, given that the building inverter battery bank voltage is 48, backup time is 5 hours, available battery is 12 volt lithium battery. Then 4, lithium battery efficiency is 95%. These are the conditions given. So now compute, that is the question. The question is compute the battery bank capacity for the building inverter system. Then 2, if the available battery in 1 is 12 volts lead acid battery with 85% efficiency, determine the required battery bank capacity. Then the question is also saying that for questions 1 and 2, take inverter load power factor to be 0.8. Solutions to the problems. The first part, number 1, the active power P given is 3,550 watts, and this one will give rise to an apparent power of 3,550 divided by 0.8, where 0.8 is the power factor and this is the apparent power. Now we have the battery bank capacity in ampere hour according to this formula to be this S times T. S is the apparent power, time is the backup time in hours, which is 5, and this is the same as this, so which is the apparent power, and eventually this is the result of this. This is the battery bank capacity in ampere hour. So now we now have a 48 volt battery bank, which is the 608 ampere hour. Now what we have is 4 number 12 volt 200 200 ampere hour lithium battery because we could have just 3 rows, 1, 2, 3, but because if we add up 200 in 3 places, that's just 600, and it remains 8 ampere hour. It depends on the designer or the client. If there's no resource enough, the 8 could be neglected and you'll be left with 600 ampere hour. So in that case, you will have 12 volts, 200 ampere hour battery. But in this case, I'm rounding up, so by having another row, so which is it gives us 16 number 12 volts 200 ampere hour lithium battery. And then if you had this 200 in parallel, so you have the total capacity being 800, 200 times 4. So by having this one now 800 instead of 602, the backup time will only increase, which is beneficial to the user. Now the second part of the question, that is number 2. The active power is the same, just like the first part. Now the battery bank capacity, now what we make the difference is the DOD, as well as then the second thing is the efficiency. The DOD, that is depth of discharge of a lead acid battery, is usually 50%. That is, usually one can only discharge lead acid battery to half of its total charge. That's 50% depth of discharge. And the efficiency of a lead acid battery is usually 85%. So if you substitute 85% into the formula, this is what the answer is. And here, if you calculate the number of 200 that can be obtained here is 5 point something. So I am deciding to round it up to 6 rows. So that's why we have 6 rows of 4 batteries, and each of the battery is 12 volts 200 ampere hour, and the 4 are in series, and the 6 rows are now connected in parallel to give a total of 24 number 12 volts 200 ampere hour lead acid batteries. And that one gives 200 in 6 places. That gives us 1200 ampere hour, and that is the size. One thing is to do the calculation, another thing is to do the sizing. So this is the size of the battery bank if lead acid batteries are used. Now, please do subscribe to my JK Multimedia Solutions channel and expect more exciting videos. Thanks for watching.